Okay, this last lesson in Unit 11 is word problems. So we're doing systems of equations, and we're looking at word problems. So let's start with example 1. What we want to do is identify two equations that we can use to represent what they're describing here, and then we'll solve those equations. So the first sentence says, the sum of two numbers is 72. The second sentence says, the difference, or their difference, is 40. Find the numbers. So just from that sentence that's highlighted in pink, we can find an equation out of that one, right? The sum means adding two numbers, add, and then is means equals. So I'm going to add two numbers, and they equal 72. And I don't know what those numbers are, so I'm going to use variables. I'll use x and y. The sum of two numbers is 72. Okay, the second statement says their difference is 40. Difference means subtraction, the answer to a subtraction problem. So their difference, the same two numbers, if I subtract them, I would get 40 of that. Okay, so to solve this, I'm going to use elimination. So I'm going to add these two equations together. I'd get 2x, the y's go away, equals 112. To find x, I'm going to divide both sides by 2. There I have x equals 56. I still need to find y, so what I'm going to do is substitute x equals 56 into the top equation. It could be either equation, but that's the one I'm going to use. So I'll have 56 plus y equals 72. And subtract 56 from both sides. And we find out that y equals 16. 72 minus 56. Okay, so there we have our two statements, and we can check and make sure that it's true. If I take 56 plus 16, does it equal 72? And if I take 56 minus 16, do we get 40? Okay, our second example says there are 13 animals in the barn. Some are ducks and some are pigs. So this maybe is not written in the best way, but there are 13 animals in the barn, and they are ducks and pigs. There are 40 legs in all. So if I was talking about something to equal 13, I could represent ducks with D and pigs with P. All of the ducks and pigs equal 13, the animals in the barn. Then it's talking about the legs of the animals. So we're going to assume that each duck has 2 legs and each pig has 4 legs. So now that we're talking about legs, we're going to say 2 for every duck, 4 for every pig should equal 40. Okay, suppose we want to solve this one using substitution. What we could do here is solve this equation for either D or P. So suppose I want to solve for D, I would then subtract P from both sides. So that statement would look like D equals 13 minus P. I'm going to put that in the D part of this equation. So I have 2 times 13 minus P plus 4P equals 40. Okay, so 2 times 13 is 26. 2 times negative P is negative 2P. Combining like terms, I would get 2P. Subtracting 26 from both sides, I'll get 14. So how many pigs do we have? 7. And if we come back up here and remind ourselves that all of the ducks plus all of the pigs equals 13, and we know there are 7 pigs, that means there have to be how many ducks? 6 ducks. And we could solve that by saying 13 minus 7 leaves us with the number of ducks. Let's check our second equation and make sure that that works too. So 2 times 6, that's 12, plus 4 times 7, that's 28. 12 plus 28 equals 40. We've got it. 7 pigs, 6 ducks. Okay. Now we've got this one. It says, the revenue for a company producing electronic components is given by this, where X is the price in dollars of each component. The cost for the production is given by this. Determine the price that will allow the production to break even. Okay, they've provided the equations already. So what we're going to do is solve this system for X. Because this is solved for Y and this is solved for Y, we could just use elimination. That's what I'll try this time. So I have to write in such a way that I can see that. Negative 20x squared minus 50x plus 200. And we also have y equals 60x minus 10. Okay, if I multiply this second equation by negative 1, then I'll have negative y equals negative 60x plus 10. And now if I add these two equations together, the top and the bottom, I can add and I will have 0, so the y's go away, equals negative 20x squared minus 110x plus 210. Okay, these are kind of big numbers, and I can see that I can divide everything by 10. We've got zeros everywhere. So I'm going to divide by negative 10. I like the coefficient of my quadratic term to be positive. So then we have 0 equals 2x squared plus 11x minus 21. Okay, if I were to solve this by factoring, remember that up top we do a times c, so that's going to be negative 42. And our bottom is our b value, which is 11. Let's see, 1 times 42, 2 times 21, 3 times 14, that might be it, 3 and 14. And for this to work, it would have to be negative 3. Divide by a, we get 7. So our factors look like x minus 3 halves and x plus 7. That means our solutions are 3 halves and negative 7. Now, according to this story problem, x is the price in dollars of each component. So would a price of negative $7 make sense? It wouldn't. The company they would pay people to purchase the product, so that doesn't make sense. 3 halves, if I were to change that to a decimal, that's 1.5. And if I put that in dollars, we're talking about $1.50. That would be the best price there. Okay, I noticed that as students were working on the assignment, they were struggling to come up with equations, so I'll just help out a little bit over here so that you can have some success. I encourage you to pause, try the problem yourself, and then if you get stuck, to look to get some help. So it says Sarah has 600 quarters and dimes in her piggy bank, which totals $123.75. How many quarters does she have? So in her piggy bank, she has all quarters and dimes, and it adds up to be 600. And when we talk about the value of each of these, we need to put value in with our quarter and dime as well. So each quarter is 25 cents, and each dime is 10 cents. And the dollar sign isn't super helpful here. Where's that? That's unnecessary. Okay, they want us to find how many quarters. So if we subtract Q from both sides of this equation, we would get D equals 600 minus Q. Then I'm going to go ahead and plug that in right there. So I'll rewrite my equation. Okay, then we want to distribute here. So we have 0.25Q plus 60 minus 0.10Q equals 123.75. Okay, so then we can combine like terms and subtract 60 from both sides. So see if you can take it from there to find out how many quarters. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and 50-50 is collected, $5,050. How many children attended? Okay, so they said that 2,200 people went to the fair, and the people that we're talking about are either adults or children, or both of them. Adults and children are the people that went to the fair. And then we have to do the equation that talks about money. So remember that adults were $4 each, 4 for adults, and children were $1.50 each, and together they total 50-50. All right, I would start by subtracting C from both sides up here so that you have an equation A equals 2,200 minus C. So substitution is what I'm going for. Then I would replace that A with this expression. Distribute and solve. Okay, again, pause, see what you can do on your own, and then take a look if you need help. An exam is worth 145 points. An exam worth 145 points contains 50 questions. Some of the questions are worth 2 points, and some are worth 5 points. How many 5-point questions are on the test? I'm going to call the 2-point questions X and the 5-point questions Y. There are 50 questions, so X plus Y equals 50. And then we've got to talk about points. 2 points for every X, 5 points for every Y, gives us a total of 145 points on the exam. Okay. As you solve this, we want to find Y. That's what we have for our 5-point letter. As you solve this, you want to find Y. So you could use elimination or substitution. So come up with your game plan about which way you want to do it. If I were using substitution, I would take this top equation and subtract Y from both sides. So it would look like X equals 50 minus Y, and then plug it in. If I were using elimination, I would want to get rid of the X's. So I would multiply the top equation by -2. Then when I add them, the X's will go away, and I can solve for Y. So both strategies work. You choose the one that works best for you. The Lakers scored a total of 80 points in a basketball game against the Bulls. The Lakers made a total of 37 2-point and 3-point baskets. Okay, so let's call the 2-point baskets X and the 3-point baskets Y. If I add up just the number of baskets, that would be 37, but then we also want to take into account the points. So that would be 2X plus 3Y equals 80. And they want to know how many 3-point baskets were made. 3-point shots did the Lakers make? Yeah. So we want to solve for Y. This one's very like the last problem. If I were using substitution, I would subtract Y from both sides of this equation and then plug it in right there. If I were using elimination, I'd want to get rid of the X's, so I'd multiply the whole equation by -2X and then add it to the other equation. Wolfrich lived in Portugal and Brazil for a total of 14 months in order to learn Portuguese. So he was in Portugal and Brazil for 14 months. He learned an average of 130 new words per month when he lived in Portugal, and an average of 150 new words per month when he lived in Brazil. In total, he learned 1,920 new words. Okay, so the top equation is talking about months that he was in each country. Now we want to talk about the number of words per country. So he learned 130 every day when he was in Portugal, and 150, oh sorry, not every day, every month, 150 when he was in Brazil, and he got a total of 1920. Okay, and they want to know how long did he live in Portugal and Brazil, so we need both answers here. You could solve this using substitution or elimination. If you were substituting, you would subtract either the P or the B from this top equation, and then replace the statement in either the P or B slots based on what you did. Now, when you substitute, you should have an equation with only one letter, right? Either the letter P, and it might show up multiple times, or the letter B, again, it might show up multiple times. But you don't want an equation that has P and B when you've done substitution. That would just still mean a lot of work. You could also use elimination. If you wanted to eliminate the P, you could multiply this one by negative 130. I made my parentheses too big. Or if you wanted to eliminate the B, you could multiply this top equation by negative 150 and then add the two equations. Once you find P or B, I'd plug it back into this equation to find out the other one. Okay, over here they're handing you the equations. X is the number of days since opening day. So on what day was the attendance the same at both pools? That's where we're going to put our X answer. And then what was the attendance? That's if we plug in X, what would Y be? Okay, so on this one, what I might do is multiply this by negative 1 and then add the two equations together. And then this is a quadratic, so you're probably going to need to factor to solve it. If you do multiply by negative 1 and then add the equations, you'll have 0 equals x squared, and then you'd have negative 39 plus 28, which is negative 11. And then you'd have negative 64 plus 4, that would be negative 60. Negative 60, negative 11. We've got 1 and 60, 2 and 30, 3 and 20, 4 and 15. There we go. 4 and 15. I'd make the 15 negative. Then you can list your factors. If you get an answer that's negative, it doesn't make sense, right? That would be going backward in time since opening day, which wouldn't fit the story. So ignore the negative answer. Just go with the positive one. Okay, that should be enough to help you have success on this assignment.